Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is a very interesting MCQ. So that's the reason I have selected this. I request everyone please pause the video. Read the question carefully. Try by yourself and whatever answer you get, please write in the comment box along with few words as explanation. I believe you have tried, so let's start. So what is the major product of these reaction? By the way, this is toluene, aromatic hydrocarbon. And if you look at this reagent, it is copper 2 nitrate and acetic anhydride in chloroform as solvent. So what is the product? Orthonitration, metanitration, paranitration, or no reaction? So this is actually a very interesting problem, student. That's why I have selected this. So this is a name reaction. Its name is Menke nitration. I guess I'm not sure whether you have studied or not this much, so that's why I've selected this. This example is very interesting. Read. Now, since it's a very unique example, so that's why I have given the reference. If anyone feel any doubt, I request please visit. And here I will not give my personal opinion. I'll just give you the information from this literature. Now, if you look at this, if R is equal to alkyl, means it's phenol, it's aniline, etc., it reacts under these condition and produce the major product is the ortho substitution. So how this reaction happens? That is the proposed mechanism. By the way, in this case also, nothing my personal opinion. Whatever I found from this literature I am showing. You may visit. So let me read first. Although it has been reported that this diacetyl orthonitric acid and acetyl nitrate might be the nitrating agent, it is proposed here that the reaction of cupric nitrate, copper 2 nitrate and acetic anhydride yields nitronium ion as the real nitrating agent. We know that nitronium ion is actually the electrophile in this nitration reaction, NO2+. How it is produced? Let's look at here. Copper 2 nitrate, by the way, nitrate means uninegative. Okay, there. So copper, this nitrate, by the way, in this case there is a mistake, student. Nitrogen cannot be pentavalent. It should not be written in this way. It should be written in this way. Actually they have written that. Remember, do not get confused. It's a wrong. Now this is O minus, so you can say this oxygen is electron rich, and in this case acetic anhydride is there. So in acetic anhydride molecule, the carbon center is electrophilic in nature. So what happens? So in this case, these O minus attacks there. Acyl nucleophilic substitution. By the way, if you have any doubt regarding such kind of mechanism, I've already made a dedicated video. You may visit for further learning. Now, okay, acyl nucleophilic substitution, it producing as a, you may consider it's a mixed anhydride type. So this side acetyl, this side NO2. Now, so it produces this, and here CH3CO minus means acetyl group comes out. Student, look at neutral compound, acetic anhydride also neutral compound. So from these two neutral compounds combination, one anionic compound is eliminated. So remaining part should be positively charged. Look at here, this is a positively charged. Now it undergo further breakage of bond. What means? This copper oxygen, by the way, this is the metal oxygen bond significantly because it can comes here, and this bond breaks and it goes to O minus that get attached to copper. So in this way, what it produces? Copper acetate nitrate. Still copper oxidation state doesn't change, so anion change. So one of the NO2 is converted to NO2 plus as the electrophile. So NO2 plus, what is the structure? This nitrogen attached to 2 oxygen and it is carrying a positive charge. So this nitrogen center is actually electrophilic. So if I say what is one side nitronium, another side acetate. So these NO2 plus will act as the electrophile and it will react with toluene. So this toluene molecule, if I say this ortho position attacks this electrophile. Now question, why ortho? Which is written that which acts preferably at the ortho position of the aromatic ring, resulting orthonitrated product as shown in the example of toluene. This is because the newly generated carbocation is tertiary carbocation which is closest to the electron donating group. Remember, it is actually an experimental observation. In order to explain that, they have given this explanation. So this is the positive charge, and if you look at, there is a CH3 group. So with respect to this positive charge, this is the alpha carbon, and here 3 alpha hydrogens are there. So you can expect 3 additional hyperconjugation possible along with the resonance, and this is the tertiary carbocation, so plus I effect you can also expect. Now in this way, this is the produce. This is actually, student, the sigma complex. Now in this sigma complex, if you look at the aromaticity of the toluene molecule is gone, and remember aromaticity is actually very high stability. So what happened? In order to gain the aromaticity, this proton is abstracted. It may be by acetate anion, so it can come here and it produces this. So here aromaticity is gained. So gaining of aromaticity is actually the driving force for this reaction, you may think. Okay, and in this case what it produced? It produced the ortho product as the major product. So this is the explanation. Now what is the major product of this reaction? Ortho is the major product. Now if this question appear in your exam, how can you solve it less than 30 seconds? First of all, student, remember this information, this name reaction, because based on my understanding also, if you do not know, it is very difficult to conclude when you have the para 1 is an option. So in this case, no tricks, no suggestion. Remember this, read this, try to understand this, and remember this information. That will be the best for you. So this is the overall discussion. I believe you have learned a lot, and if you really consider the content of my channel worthy, please help this channel to grow. And regarding any doubt about the logo of my channel, please read this part. Your doubt will be clear. So see you in my next video. Bye bye.